Hi, my name is Sophia. I'm a member of Ri3D at Penn State, and today I'm going to be talking about our climb mechanism. Okay, so over here, you can see that we have about 3 components to this climb. The first one I'm going to go over is the pulley system. So the pulley is powered by a Neo with a 100-to-1 gear ratio, and as you can see here, it has a bit of a secondary tension and then is connected to the linear sliders. That was just to give us a bit of a straight going up to that portion there. So one of the issues we came to when we were printing out these pulleys was that the prints kept failing, and with the massive weights of the robot, it couldn't always hold it and would slide. So we had to add an additional hex plastic core to the center, and then that was able to hold it. The next portion of the climb that we can go into is the linear slider part. This is a pretty standard kit linear slider. You can't really see it from this angle, but there's the regular bearings and the cylinder rollers in there. And you can get that from a couple of different types of kits. And basically what we did with that was assemble it and used a couple of cross bracing to keep that stable. And it's tensioned with a constant force spring. And we had a couple of issues with that, with the constant force spring not keeping its tension. So we had to add some additional surgical tubing, and that was able to keep it steady. So, and then the last part is the hook. That was custom made, and it works pretty well for the chain. The only thing we ran into, problem-wise, was that as the hook would come down, I can't really show it here because it's tension, but the chain would catch on this part. So what we had to do was add this additional cross bracing with just regular straight brackets connected with a couple of nuts and bolts. That worked pretty well, but those are a couple of the problems we ran into. One other thing we decided to do was with harmony, you have to have a pretty stable climb. So we had to figure out how to alter our center of gravity. Obviously, we can't really perform harmony with our singular robot, but we had to figure out the right way to lift the arm and alter the center of gravity before climbing, or before attempting to climb. So by having the arm at about this angle, the center of gravity is positioned around where the hooks are, so that means our climb will be more stable. And that's about it. You'll be able to see the climb run in our final video, our final reveal video. Yeah.